Hey everyone, it's Miss Helen again. And pretty much I'm here to give you guys another overview slideshow presentation before you guys get back to school on your in-person days. So last time we went over Newton's first law. Now we're going to go over the background knowledge that you need for Newton's second law. And if we take a look at Newton's second law, it says the net force of an object is equal to the product of its mass and acceleration, or F equals ma. So basically, before we can even get into F equals ma, we need to know what net force is. So that is the purpose of this video. So if we take a look at this slide, it says the net force acting on an object is the combination of all the individual forces acting upon it. So if we take a look at this race car driver, he is driving, and there is 10 newtons of force, presumably from the engine, pulling him forwards or pushing him forwards. We also have 10 newtons of force from the turbo booster here, pushing him forwards as well. And we have 7 newtons of force pulling him back from the parachute. So one thing that we can do, and when we are calculating net force, is it helps to add up the forces that are going in the same direction. So if we look, this 2 forces going to the right are both in green. So actually I can make my pen be green. So we have 10 newtons from the engine, and we have 10 newtons from the turbo booster, and that gives us a total of 20 newtons to the right. Okay, so down here we have a total of 20 newtons going to the right. And again, our little arrows do show the direction, so it's helpful to draw them. All right, then on the left, we have the parachute, and it is pulling to the left, and that is just a total of 7 newtons. There's nothing to add, nothing to subtract yet there. It's just one force going to the left with 7 newtons. So at this juncture, we need to figure out what the net force is. What is the final force that's going to make this race car move? Is it going to go to the left? Is it going to go to the right? So basically, we compare 7 newtons to 20 newtons. We have 20 newtons pushing the car to the right and 7 newtons pulling it to the left. So if we compare 7 to 20, we obviously know that 7 is less than 20. 20 is greater. So the car is eventually going to move to the right. But now we need to figure out with how much force. So we can't just pretend that the 7 newtons is not here. It is here. It's slowing down the car. So basically what we do is we just subtract. We do 20 minus 7. And we get a total of 13 newtons. And it's going to go to the right because that is the direction of the larger forces. So that is essentially how we calculate net force. We add up the forces that are going the same way, and we subtract by the forces going in the opposite way. Whichever side is larger, essentially the object moves in that direction. So that's how we do it. All right, next is going to give us some specifics on what to do when we have forces going in more than one direction, etc. So here we go. So when we have 2 forces acting on an object in opposite directions. Oh, let me clear out this. Hold on. You probably don't want to see all that from the race car. Covering up our cute little dogs and our soccer players. All right. So when we have 2 forces going in opposite directions, we always need to subtract. Okay, so just like when we had the 20 newtons at the end minus the 7, we want to subtract. So we find the difference between the 2 forces. And in this case, the net force is always going to be greater than or equal to 0, but less than either of the individual forces, because you'll have some cancel out. So if we take a look at these 2 dogs, we have a larger dog and we have a teenier dog, and then even bigger dog in the background, but he's not playing, so he doesn't really count. The larger white dog can pull with 12 newtons of force on the tug toy, and the smaller dog, pretty formidable, can pull with 10 newtons of force to the left on the tug toy. But just because of sheer size, the larger one is going to win because we would do 12 minus 10, and our final answer is going to be 2 newtons of force to the right. Okay, so that is the final net force. 2 newtons of force to the right. You have to give the direction as well as the actual strength. So 2 newtons of force to the right, that's how this tug toy will move. In terms of our soccer players, we have the person on the red team. He's going to kick the ball with 125 newtons of force. We have the person on the yellow team. He's going to kick the ball with 75 newtons of force. Well, all we need to do is some subtraction. We would do 125 minus 75. And these get away. 12 minus 7 is 5. So we're left with 50 newtons of force, and we need to determine which way the ball is going to move. It is going to go to the left because 125 was the bigger number to begin with, so it's going to go to the left. And I'm okay with you either putting arrows or actually saying to the left. But typically when we're online, you're just going to need to type out 50 newtons to the left. Okay, so that is when they are going in opposite directions. However, when they're going in two forces going in the same direction, we're not going to subtract, but rather we're going to add. So just like our little race car friend. So in this scenario, if two forces act on an object and they're moving in the same direction, the net force is the sum of the two forces. So it is, you add it, sum meaning addition. So in this case, the net force is always going to be greater than either of the individual forces because you're adding them together. So over here, we have two movers. One is pushing with 25 newtons of force going to the right. The other is pulling with 10 newtons of force going to the right as well. So all you do is add them together because they're both going in the same direction. So they're additive. 25 plus 20 is 45 newtons to the right. Simple, just like that. So being able to understand what net force is going to help us when we get back to school and we learn about Newton's first law and Newton's second law, more so Newton's second law. So remember, after this video is done, you guys can take the exit pass that is up on Classroom as well. And don't forget to also fill out your daily attendance form too. All right, guys, I will see you when you get back to school. Have a good one.